Hi, this is Noelle, and today I'll be talking about regular polygons and the century theorem. So to start off with, what is a regular polygon? A regular polygon is it's an equilateral and an equal angular polygon. Now, these two words mean that the polygon has all the sides of a polygon and all the angles of the polygon is equal. So take for example a triangle. A regular triangle that is equilateral and equal angular means that it is all the sides, so all three sides would be the same length and all three angles would be the same degree. And another example is a hexagon. And since it's a regular polygon, that means all 6 sides of the hexagon is the same length, and all the angles are the same as well. So a regular polygon can be applied to any polygon of any number of sides and number of angles. So right now, the number of sides / number of angles would be n. So n represents the number of sides and angles. Going off of this, the century theorem is a theorem based on the degree of the angles of a regular polygon. So basically it's saying that all exterior angles of a polygon will add up to be 360 degrees, and all the interior angles, the sum of the interior angles is n minus 2 times 180. Now to prove this, here is an example of this problem. Let's just go by the same two polygons, a triangle and a hexagon. To start off, let's do a triangle. So the sum of the exterior angles of a triangle would be n minus 2 times, so this would be the sum of the interior angles, and since it's a triangle, there are 3 sides and angles. So plug that in, and 3 minus 2 times 180. That would be 1 times 180, which would be 180. So that is the sum of the interior angles of a triangle. And the second part of the theorem is that all of the exterior angles is added up to 360. So to find every individual angle of the exterior angles, just divide 360 by n, and in this case n is 3, so 360 divided by 3 would be 120. So next we're going to find the individual degree of an equilateral regular triangle. So we know now that all these angles added together becomes 180 degrees. And an exterior angle, the exterior angles of these polygons, which I'll put as red, is 120 degrees. So these are all 120 degrees, 120 degrees. So just a simple way of finding the individual degree of these is to put 180 divided by 3, because there's only 3 of angles, which would be 60 degrees. Another way to figure this out right away is to plug it into the century formula, which is n minus 2 times 180 divided by n, which is what we used right now. So another example of this whole thing would be a hexagon. A hexagon has 6 angles and 6 sides, so n would be 6. So n minus 2 times 180. N is 6, so plug that in. So it'd be 6 minus 2 times 180, which is 4 times 180, which leads to it being 720 degrees. And 720 degrees divided by 6 is 120 degrees. Now this essentially is 720 is n minus 2 times 180 divided by n, which is 6. So this whole thing is the century theorem, and this part as well. And the second part of the century theorem is the exterior angles. So the exterior angles of the hexagon would be 360 divided by 6, which would be 60 degrees. So if we put everything into perspective into a diagram, the hexagon would look something like this. Oh gosh, this is a terrible diagram. Let me just do this again. So the interior angles would all be 120 degrees, and the sum of them would be 720 degrees. And an exterior angle of this regular polygon would be 60 degrees. Oopsies. 60 degrees, which means if you add an exterior angle and an interior angle, the sum has to be 180 degrees because it's on a straight line. And that is the century theorem and regular polygons.